Just like learning SQL is best done by looking at some actual queries, I think it's even better if you can try them out on some databases that already exist. So we're going to do just that. I have myself pointed here to a server that we have running for this class. This is an actual LAMP server. It has an instance of Apache, MySQL, and PHP all running on it. In prior versions of the class, we in fact used this as our main source whenever we had to do AJAX queries, whenever we had to run PHP, and it was very inconvenient. This semester, we've actually managed to avoid that. We do still need to use it for our database. It's too complex to have you guys set up your own database server. So the MySQL server on here is still something we need to use. Now at the current point in time, we access it with its IP address, 144.13.22.59. And when you first pull it up, you'll see this. You guys won't be able to do anything here, so don't worry about this page. This is for administration. Also keep in mind that this might change over time. And in future semesters, it might be at an actual URL, it might be at a different IP address. So make sure you check the course info to make sure you're looking at the actual one that you're supposed to be using this semester. Let's go to a few different pages on this server. You will find there is a directory called examples. And inside here, there are 3 or 4 different examples that we can play around with. The first one I'm going to go to will look very familiar. This is the Simpsons database that we were just looking at in the slides we were going through. It's called examples Simpson SQL.php, and I'll have a link to that in the course information as well. Here's a rough overview of what this database looks like, showing you the entities and how they're connected to one another, which is something we already talked through in the original sort of talking that we did earlier. In addition, I want to show you what this looks like when we examine it under a more robust industry tool. Specifically here, I have the MySQL Workbench. This is a tool that's free to use that comes with the MySQL implementation and visually shows you all the information that's in the various tables of your schema. So here we're looking at the Simpsons schema itself. Inside students, we have what we expect, an ID, which also includes a type. I'm not going to focus on these types very much though. A name and an email as expected. Incidentally, this particular database comes from a textbook called Web Programming Step by Step. You'll find that quoted down at the bottom here with some source on to get to it. This particular database was described exactly the way you saw it in the slides, in their slides as well. But I found, as I examined it, that there was extra information, namely password right here. This password is actually something that's used in examples in the book, but it's never mentioned in the slides. We're going to be using it in this class as well. So notice there's one extra bit of information that wasn't mentioned in the slides, a password for each student. Beyond that, we have grades, which are connected to a student, and which are connected to a course. You can see here, if you go over the ID, you can see how they reference things. So student ID references student's ID, course ID references course's ID. I will also point out that when I talked about these entities in the slides, I called them student and grade and course. I find that to be much more reasonable, not plural. But unfortunately, this particular database, as it was made, already called them plural, so I'm going to stick with that. Everything else is exactly as it was before. Teachers have a name and an ID, courses have a teacher ID, a name, and an ID for themselves, and then the grades are just glue between students and courses. You can see here they have no primary key themselves, but their primary key is actually composed of the student ID and the course ID combined. So what can we do with this? Well, on this page, you'll be able to issue queries against this database. Those will be sent to the MySQL server, and you'll see what you get back. It's pre-populated with a real simple query, all the data from students. And you can hit submit, and you will see exactly what it returns. We'll always show this to you as a table. So this is the exact student table right here. And we can read their passwords. That should cause you to gasp. Actually, this database stores their passwords in plain text. So obviously this is not a real world example. You should never do that. That's like faux pas number 1 in web management. I hopefully don't even need to tell you that. So don't pretend like this is a real database. It's not. After you've actually submitted it, you'll still see your query listed up at the top, and you'll be able to edit it or submit a new query. If you hit edit, really it's just like we saw before, it's simulating your back button so that you get back to the original query. If you hit new query, it just reloads the page from scratch. So let's do some other things. Let's select name and password from students. If we submit that query, you can see now I have everyone's name and password. Woohoo, I'm running to the store here. We're going to start opening some credit cards. All we really did here was reduce that table a little bit. We took out the things we didn't need. ID is gone and email is gone. So all I see is a name and a password here. Let's go ahead and go back and do some more here. Let's start looking at, let's say, the courses table. So let's select name from courses. And if you're forgetting, exactly what is in all of these things, it's all listed down here. Courses has ID, name, and teacher ID. So if I select name from courses, here's the names of all the courses in the database: 142, 143, 190M, and 100. Let's go a little bit further here. Let's say I want to get the name and, as we said before, the name of the teachers. So I'd like to do teacher.name. Now, of course, that all doesn't come from one single table, so we're going to have to join. We're going to have to join courses with teacher, and we have to join it on teacher.id equals teacher underscore ID. Now, both teacher.id and the ID here needs a teacher dot on it. Otherwise, we're going to have a problem because ID is not unique. Teacher underscore ID is unique. There's only one table that has that name, at least that we're working with, and that's courses. Lastly, I could give it any additional sorts of where clauses. I actually just want to see them all. And let's submit this. Now we have an error. Did you spot it when I was submitting them? There was an error. When SQL errors occurred, normally it would just say to the user, sorry, something went wrong. And it wouldn't give them any additional information because any extra information about what went wrong might be potentially insecure. However, this is more for educational purposes, so we actually do give you info, but it's in the source of the HTML page. So we're going to have to go view the page source. You'll see there's a comment that tells you what's wrong. Basically, it says simpsons.teacher doesn't exist. And this is that case here where they named everything plural and I didn't. So let's go back and do that. It's going to need to be teachers.name and teachers.id. And it is still just teacher, not plural ID on here. And then we need to change this to teachers as well. I think there's still one other error in here, but let's see what we get. Yes, we do still have an error. Let's view the page source again. Column name in field list is ambiguous. So that's one of those cases where we have two things named name and we didn't specify. We did call out teachers.name, but here we didn't call out courses.name. Now let's submit. There we go. Now this always creates a bit of a problem, and we'll cover this in just a moment here, how we deal with this. So you can see here, name is Krabappel, Hoover, Stepp, and Krabappel. But unfortunately, I lost the actual course names. Why is that? Well, I called them out specifically up here, but they're still name, and so the two conflict with one another and can't be returned simultaneously. There's a couple ways we could get around this. We could do courses.id instead, and that at least allows me to see the course ID, but I have to know which ID is which. At this point, the only thing we can really do is we can say courses.name as course name, or we'll just call it course, as course, and teachers.name as teacher. And if we submit the query like that, then we've renamed those parameters to something else, and both can show up in the same query. Unfortunately, this is just the nature of joins. Whenever you join two tables together, you will almost always run into these kinds of conflicts where you have to be more specific by putting the table name on the front. And you might have to rename things by saying as course. All I'm doing here is giving an alternate name to courses.name and here to teachers.name. Just be careful about that and remember when you need to do it. Make sure you examine your output and that all the columns are there that you expect. And if they aren't, probably one of the reasons could be that you have a name conflict. And if they have the same name, the last one is the only one that will get included. So here we are now. We see all of those. And I remember in the examples, we wanted to do ones that were taught by Krabappel. So we can say where teachers.name equals, and I have to spell this right, Krabappl. Maybe? Nope. Results returned to 0. LE. No, that's not right. They don't spell it the way I would expect. A-P-L-E. Nope. Let's see here. Let's go back. Let's take out our last clause here. I'm going to comment it out. This is how you do comments in SQL. Submit the query, or not. Why is it not like that? You have an error in your SQL at line 3. It doesn't seem to like that. I thought that's how you did comments. Apparently not. There they are. Okay, yeah, you just need a space after it. K-R-A-B-A-P-P-E-L instead of L-E. I before E except after C. No, that's not right. So E-L, apple. Yeah, and it is 2 P's. I would prefer L-E because that matches the fruit, right? Apple. And she's supposed to be a crab apple, but whatever. There we go. So now we can see the courses that are taught by Ms. Krabappel. We've got Computer Science 142, Informatics 100. So this starts to give you an example of how complex these things can get. How about we try that one last query that we had in there that joined all 4 things back together? That was a big old query. Let's see if we can get it in here. So I probably got an error in here. I don't think I ever actually tried this one, but we'll find out together, and we'll debug it together. So this is all of the grades earned by Bart from Mrs. Krabappel. So select student.name and grade from student, join grade course teacher, and then we want student.name to be Bart and teacher.name to be Krabappel. We do have an error. Let's see what our error is. Table Simpsons.student doesn't exist, so it's the plural thing. So let's just go back and fix that real quick. Students, there's a lot of changes here. Grades, courses, teachers, courses, students, teachers. Submit. Nah, we still don't have it. This is kind of how it goes with these things. Unknown column Bart in where clause. Oh, this is a problem from PowerPoint. It changes my quote marks to be something different. So students.name equals Bart. I need to turn those back into traditional quote marks. And teachers.name equals Krabappel. At least I'm guessing that's where that comes from. Submit query. There we go. Bart earned a B-. Now I'd like to confirm that this actually was from Krabappel, but if I try to do that, I'm going to get the same problem I did before. If I try to do teachers.name in addition to students.name, I'm only going to get one or the other. In this case, the teacher again, because I believe that was the second one issued. So we should say as student, and then teachers.name as teacher. Submit that query, and there we go. Bart, Krabappel, B-. In addition to renaming the columns like this, you can also rename the database tables themselves. Now this is something that doesn't show up in the final result, but can help you make your query a little bit smaller here. I'm going to go ahead and put this on another line so that we can see pretty clearly what's going on. So let's say we'll do students as S, join grades as G. And then this is going to be s.id equals student ID, courses as C, and then this could be c.id equals course.id, and teachers as T, and this will be t.id equals teacher ID. And then here I can say s.name and t.name. So basically I've abbreviated all of these tables according to their first letter. I can also shorten this then to s.name and this to t.name. And by doing that, I've basically been able to make this particular table a little, or the query itself rather, a little more compact. There's really no other benefit to doing this besides that, so keep that in mind. But it is helpful if you're having to repeat a whole lot of things over and over again. So feel free to do that if you like it. If you find it confusing, don't worry about it. You don't have to do this. It's perfectly okay to always spell the table names out. The table names will always be unique too. It would be impossible to have 2 tables with the same name in the same schema because you wouldn't be able to distinguish them anymore. Names are used profusely to uniquely identify the table. Now this is not the only database that's out there. You'll find that there's other ones out there as examples as well. And one that's going to be important is the little IMDb. Again, I'll have a link to this elsewhere. The diagram for this is a little more like the actual diagram that you'll get from the MySQL implementation of this. Let me show you what this looks like over in the full MySQL workbench. So this particular database is a lot more complex. It is a movie database. It's going to have movies themselves sort of as the central entity. Then we also have actors as entities and crew as entities. In addition to that, there's a few other tables that sort of represent entities, but are actually just those glue tables that glue things together. For instance, an actor can be in a movie, but they can be in many movies. And movies have actors, but they have many actors. So this is a many-to-many relationship, actor and movie. And that always has to have some sort of intervening table between them to handle that, which is what the movies actors table is about. In addition, it also lists the role that that actor played in the movie, so it does have some useful extra information. Similar thing happens with the crew. The crew on a movie, there's many of those, and every crew member probably works on many movies. And so we have another one of those glue tables that allows you to take a many-to-many relationship and make it manageable. In addition, this particular database has something interesting. We have genres. Every movie has several different genres assigned to it. It sort of is a one-to-many relationship. Similarly, we like that information about a crew. We'd like to know what director, what genres does that particular director like to work in, and so we have those genres connected directly to him. Now that's somewhat redundant information. We could have joined these 4 tables together to actually figure out which ones he worked on, but having sort of pre-computed that here is a little useful. These are all practices that you'll see in modern databases, real-world databases, where something that was important that you'd like to maintain separately is kept here. There's a little bit of redundancy between these two that could be avoided. Really, for best practices, it should be. But we have it here anyways, just as an example of something you will see in real databases. So let's go ahead and just submit the default query so you can see what we have here. This is going to grab some key information out of the movie table. In here you will see we have the title of the movie, a quick plot synopsis, the year it was released, and an MPAA rating, or really a certification if there is no MPAA rating. Sometimes that'll be a TV rating, sometimes it'll just be passed or approved. There are a lot of movies in this database. This database is actually a list of every single Best Picture nominee in the history of the Academy Awards. So it goes all the way back to 1927, and it comes all the way down to the current one, which was 2016, because we haven't finished 2017. For all of these, everything back up to 1968 will have a standard MPAA rating, which is the usual R, PG, PG-13, G, and all of that. Before 1968, movies were not rated on that same scale. And so you will find that sometimes they have TV ratings, sometimes they have gone back and rated them, so you will see an MPA rating, and sometimes you'll see unrated, or you might even see ones that have a blank entry here, which means it's a movie that has never received any sort of certification at all, which does happen. This particular database is actually a recreation of another one that came from the Web Programming Step-by-Step book a long time ago called Tiny IMDb. The problem is that particular database was getting old, and it was full of mistakes, and it was, in fact, very tiny. It had maybe 20 movies in it. This one has 531 movies. Let's go ahead and play around with this a little bit so we can see some of the other things that we can do with our setup. So here we're selecting all of these from the movie database. Let's use one of the other ones that we pointed out, the order by clause. This allows me to sort the results, and it means the results will take a little bit longer to give back, but it allows me to see them in a particular order. So let's order by year. They're close to ordered by year when you get them raw, but not quite. There we go. Now we can see them truly ordered by year as they come out here, and you'll see that 2016 is all the way down at the bottom, and there are 8 of them, because we've expanded to this special situation where we include 8 different movies for Best Picture nominees. Let's go a little bit further and let's say where year equals, and let's see what the nominees were in the year I graduated from high school, 1998. I believe American Beauty is in there. Yeah, or not. So we have Saving Private Ryan. Yep, that's right. The Thin Red Line. I don't remember that one before. Elizabeth. That was an interesting movie. Shakespeare in Love. Yep. Let's see. It was 1999 American Beauty. There it is. Yes, American Beauty. I was like, I know I remember it being in there somehow. So now we can look at them by year and see what we've actually got. Let's take a look at and actually confirm that there are as many as I say there are. Let's select just ID from movie, and let's not filter or order by anything. This is just going to list all the IDs. These IDs are actually the exact IDs they use in the Internet Movie Database, which is why they're prefixed with TT. And you could go put these over into an IMDb URL and pull out the actual movie and all of its information. Now let's edit this a little bit. Instead of getting the IDs, what I'd really like to know is how many are there. Here comes the count function. I can say the count of ID. And now I'll get a single row back. That is 531. That's how many nominees there have been. Let's see what else we could do. Let's go ahead and take a look at year instead. If we put year in there and count it, we'll get the same result because there's the same number of years in there. That only just counts how many years there are. But let's try min year and max year. And this will tell us the earliest and latest year. And there we go, 1927 and 2016. Now, min and max are only going to work on numerical columns, so this wouldn't work on, say, title or plot or something like that, because those don't make any sense to say what's the min and max of those. We could also do average. That's kind of a meaningless number for something like this, but at least, hey, we've got that. Submit query. So it's 1970s right in the middle here. Now keep in mind that's going to be skewed a little bit towards the modern era because there have been more nominees in the modern era than there have in the past. That's why it isn't the exact midpoint between the two. What else could we pull out here? There's a particular column called IMDb rating. I didn't show that one before. This is what the users of IMDb have sort of ranked this as. It's a 0 to 10 ranking of the movie and how good they thought it was. This is something that could be interesting. We can ask ourselves, what's the minimum IMDb rating? What was the worst movie? Well, in fact, there's several that are 0. I believe this could be an error in my own trying to scrape the information out. They could also just be movies that have never been reviewed because IMDb very much is a much more modern thing than many of these movies. Some of these movies are rather obscure because they were the nominees, not the winners. Let's look at something else. What was the max? What was the best rating it ever received? 9.3, so no 10s. They're very stingy with their ratings. So this gives you some idea. What's the average rating? Keeping in mind, this is actually going to be skewed somewhat by the zeros. 7.6. So that's not a bad average. Considering they're Best Picture nominees, I suppose we'd expect that. Is there some way we could actually get it so that we could keep the zeros out of there? Well, we can. Let's create a where clause. Let's say where IMDb rating is greater than 0. And that'll simply eliminate the 0 values. We submit that query, you can see it does go up ever so slightly, 7.62. And what was it before? Let's just comment out that bottom half. Before it was 7.61. So it didn't go up by much, but it did go up. And then we keep those zeros out of there. So you start to see what some of these extra little bits can be done here with this more complex database. Now the joins get really interesting on this particular database. I'm going to leave those up to you guys. You're going to be using this database to answer questions in your homework and in other places in this class. So you're going to want to spend some time with it, get familiar with it. I think that's a good thing to do before you get too deep into the assignments themselves.